Hey there, and welcome. Today, we're going to pull back the curtain on the magic that makes modern video streaming work. You know, the tech that lets us watch billions of hours of content every single day. We're going to talk about the ABR revolution, the thing that finally killed the buffering wheel for good.
Oh, the buffering wheel. We all know this guy, right? You're at the best part of a movie, the big reveal, and bam, everything just stops. And you're left staring at this spinning circle of doom. It was basically the universal symbol for internet frustration. And it's the exact problem that video engineers were desperate to solve.
You see, in the early days, streaming was really just a glorified download. The server would send you one single massive video file. If your internet connection was amazing, great, no problem. But if it was slow or maybe a little unstable, you were stuck, just waiting. It was this one-size-fits-all approach, which, let's be honest, never works on the internet.
All right, so here's our game plan for this explainer. First, we're going to really define that buffering problem. Then we'll introduce the awesome solution, ABR. We'll meet the two big players in that space, HLS and DASH. Then we'll see how they're finally starting to work together, and we'll wrap up by talking about your role as a developer in this whole process.
So the root of the problem was this total mismatch. You had services sending out just one version of a video file, but it had to play on everything. You know, from a tiny phone on a shaky 3G connection all the way to a giant smart TV with a super fast fiber line. That kind of approach was just destined to fail.
And that brings us to the hero of our story, Adaptive Bitrate Streaming, or as everyone calls it, ABR. This is the tech that completely changed the game, making video streaming reliable and high quality for pretty much everyone, everywhere.
So what is adaptive bitrate streaming, really? Well, at its heart, it's a super clever method that makes the video player itself intelligent. Instead of just blindly downloading one huge file, the player is constantly watching your network conditions and adapting in real time to make sure the video just keeps playing no matter what.
So how's it work? It's really just a simple three-step dance. First, on the server side, you take the original video and you create a bunch of different versions, from a low-quality one all the way up to beautiful 4K. Step 2, you chop each of those versions into tiny little pieces, usually just a few seconds long. And finally, this is the magic part. Your video player is constantly checking your internet speed and seamlessly switching between those different quality chunks to give you the best picture it can without ever having to buffer. Now, this fantastic idea needed some rules to work. You know, a standardized way of doing things. And that's where two major protocols showed up to lead the way. For years, they've been the two kings of ABR, HLS and MPEG-.
First up is HLS. That stands for HTTP live streaming. This is Apple's baby. They developed it, and because it's baked into the operating system of every iPhone, iPad, and Mac, it has just massive support. It traditionally uses these video segments called transport streams, or .ts files for short.
So, how does your phone's video player know what to do? It gets a little roadmap. HLS organizes everything in a file called a manifest, and it ends in .m3u8. You can literally just think of this as a playlist. It's a simple text file that tells the player, hey, here are all the different quality levels available, and here's exactly where you can find every single video chunk for each one.
And then on the other side of the ring, we've got MPEG-. The big difference here is that DASH is an open international standard. It's not controlled by any one company. It's super flexible and usually uses fragmented MP4 files for its segments, which is a format that's a bit more web native. Its manifest file is XML-based, and it's called a Media Presentation Description, or .mpd.
Okay, so let's put them side by side. You've got HLS, which is Apple's world. If you want to stream to an iPhone, you're using HLS. Then you have DASH, the open standard that pretty much dominates on Android and in web browsers. But for a senior engineer, the most important row on this table is that last one, DRM, or Digital Rights Management. Because HLS is an Apple tech, it's tied to their FairPlay DRM. For everything else, you're likely using DASH with systems like Google's Widevine or Microsoft's Play Ready. And this split is exactly what led to our next big innovation.
For years, this whole divide just meant more work and more money for developers. But thankfully, the industry is moving toward a more unified future, and it's all thanks to a standard called CMAF.
So here's the headache. To support both Apple devices and everything else, you literally had to encode and store two complete separate sets of video files. You needed your .ts files for HLS and your .m4s files for DASH. That means double the encoding time and double the storage costs. It was inefficient, to say the least.
And CMAF, the Common Media Application Format, is the really elegant solution.
Now, it's not a new streaming protocol, it's actually a standardized format for the video chunks themselves. And its superpower is that it lets you use the exact same set of video files for both HLS and DASH.
I mean, this slide says it all, right? Before CMAF, you had these two totally separate pipelines, two giant piles of files. After CMAF, you just have one single set of media files. Now, you still need two different manifest files, the M3U8 for HLS and the MPD for DASH, but they both point to the same video chunks. It simplifies the entire workflow like you wouldn't believe. And here's the bottom line. This is the part that makes the business folks happy. By getting rid of the need to store a whole separate copy of all your videos, CMAF can literally cut your storage and your content delivery costs in half. For any big streaming service, that's a massive, game-changing amount of money.
Okay, so we've got all this theory down, but where do you, as a back-end developer, actually fit into this whole picture? Well, your role is in a process we call packaging.
So packaging, or sometimes you'll hear it called content preparation, is this entire workflow. You start with one source video file. The first step is to transcode it, creating all those different quality versions we talked about. Then you segment it, chopping everything up into those little chunks. And finally, you generate the manifest files that tell the player how to put it all back together.
And the undisputed champion, the tool that everybody uses for this job, is FFmpeg. It's a free, open-sourced command line utility that is basically the Swiss Army knife of video. It can handle pretty much any format you can throw at it and do all the steps we just talked about.
And what's amazing is how powerful this whole process is. You can feed one single source file into your packaging workflow, and out the other side comes a complete, ready-to-go stream. We're talking hundreds of little video chunks, plus the manifest files that act as the map. The whole package is then ready to be sent out to any device in the world.
All right, so let's just quickly recap the main points. ABR is what solves buffering by letting the video quality adapt to your network. The two main ways to do this are HLS from Apple and DASH, the open standard. CMAF is the new kid on the block that unifies them, saving a ton of money, and developers use tools like FFmpeg to do the actual work of packaging it all up.
So we've pretty much perfected the art of getting video from a server to your screen without it ever stopping. Which leaves us with one final thought. Now that delivery is mostly a solved problem, what's the next big challenge? Is it getting latency down to almost zero for things like live sports? Or maybe new immersive video formats? The story of video engineering is definitely not over. Thanks for joining me.